Hi, my name is Matt Forden, and I am an applications engineer at SIMPLIS Technologies. In this short video, I will be going over some of the major updates that will be released with SIMmetrix SIMPLIS version 8.4. The items that will be covered in this video are shown in blue. Those items are the capacitor and inductor conversion tool and the power supply sources and loads. The items in green, the magnetics design module and C-code DLL defined digital devices, will be covered in separate videos. The items in gray are also new features in version 8.4. However, they will be covered in a future webinar. Let's go ahead and take a look at the capacitor conversion tool. Currently, the way you define a piecewise linear capacitor in SIMPLIS is by using its charge versus voltage characteristics. If you do not have those characteristics readily available and only have capacitance versus voltage, you must use a separate spreadsheet to derive the information needed. With this new tool, you can enter the capacitor's capacitance and end up with a piecewise linear capacitor ready for SIMPLIS simulations. Let's go ahead and take a look at an example. In this circuit, we have a self-oscillating converter, and on the output, we have these two multi-level capacitors here. What I want to do is actually change this output capacitor which is a linear capacitor just at 1 milliohm. And what I want to do is change it to a capacitor that I actually have a capacitance versus voltage datasheet curve. So something that's more lifelike. I want to go ahead and just run my simulation. I'm going to run a pop and AC to get a baseline curve to see kind of where we're looking at. All right, so there's our AC data. That's what we want. So I'm going to move this over. Now I'm going to go ahead and replace this capacitor with a piecewise linear capacitor. Press OK, and I'm going to go ahead and drop it down and put it in place here. All right, so now I'm going to double click on this, and this is still the same multi-level piecewise linear capacitor interface here, but now what's different is if I come into how we actually define charge versus voltage, we have an extra button down here. This is the button to open up the tool. Okay, so first thing I'm going to do is click on that, and what we'll notice is that this capacitor doesn't have any capacitance versus voltage information. All it has is a charge versus voltage characteristic. So from here, what I could do is if I wanted to see how this charge versus voltage looks like in the capacitance versus voltage world, I could click this left button and find what the stepped curve of capacitance versus voltage is compared to this piecewise linear charge versus voltage curve. And we can actually visually see that by clicking on this plot PWL characteristics. So down at the bottom, we have our charge versus voltage piecewise linear curve, and then our capacitance versus voltage stepped curve. Right. But we actually want to input capacitance versus voltage. Now I could just input that information directly here, but if you have a pro or an elite license, you can actually utilize the digitized datasheet curve tool that's built into the program by clicking on this button, and then I have an example capacitor datasheet curve. I'm going to go ahead and open that. Now this is the standard digitized datasheet curve that I'm using. It found my boundaries nicely, so I'm going to go ahead and press continue. Now I'm going to add points along this curve so it knows what to digitize. All right, that looks okay. I'm going to go ahead and press OK. Now I'm going to put my minimum and maximum horizontal and vertical axes information. So this goes from 0 to 30 volts. And it goes from 0 to 6 millifarads. Press complete here. All right, so now we have our digitized data sheet here, all the information from 0 to 30 volts. All right, now I want to use this information to calculate the charge versus voltage. So I'm going to do that by pressing this right arrow. You know, it's this update. Now from here, we'll talk about what's located in the middle. There's two pieces of information we need. We need to know how many piecewise linear segments do you want. That's going to be an integer number. And that's gonna, the more I change this, it's gonna update my information over here. And then if you want it, we also give the ability to limit what voltage you want to piecewise linear curve fit up to. All right, if we remove this, turn this off, it's going to it's going to use all of the information in this curve or in this chart over here from 0 to 30, and we can actually plot each one of these as well. All right, but my converter only goes up to 5 volts, so I want to actually limit this voltage to be 5 volts. The reason I'm doing that is to have the most accurate piecewise linear curve fit that I can. If I go all the way up to 30 volts, I'm losing, or I'm introducing a lot more error that I don't need. What I can also do now here is kind of look to see how close our charge versus voltage piecewise linear curve fit is doing. Now we can see this one is really well lined up. And I can drop this as well. Let's say we'll go down to 2. Let's see how well that does. It's still pretty good, but you can see now we're starting to add a little bit of error. So I think if we go to 3, we're not introducing too much error, and we have a nice, we're not introducing too much simulation time by having too many segments, piecewise linear segments. So I think we're good here. I'm going to go ahead and press OK, and that information gets placed into the charge versus voltage dialog here. Press OK and press OK. Oh, sorry, I'm going to come back in here real quick. And our series resistance on our old capacitor was 40 milli, so I'm going to go ahead and keep that the same as well. So that way we can see that it's pretty close. Now all I need to do is go ahead and run my simulation again. And we can now see that our updated capacitor is being used, and there is some slight changes based on the new capacitance that we're seeing. Alrighty, so I'm going to actually leave this open to discuss the next item here, but I am going to pull it off and so I can see, and we'll do this. All right. So next thing we're going to talk about, well, the next item is the inductor conversion tool. Now, this tool can also be used when you need a piecewise linear inductor. The tool will take the inductance versus current characteristics and convert it to a flux linkages versus current defined piecewise linear inductor, which could then be used in SIMPLIS. We won't review an example of this as it is very similar to what we just went over. So we'll now move on to the next major development, which is the power supply sources. This slide shows all of the possible sources that are now available. There are 6 AC sources and 12 DC sources, all of which contain internal voltage and current probes, each with selectable measurements. So what we'll go ahead and do is come back to our example, and we're going to update this example, our power supply, or our source here, with a power supply source. So I'm going to go, or where it's defined as Vn, right? So we have a variable Vn. So I'm going to go ahead and delete that source, and I'm going to come up to my part selector and choose power supply sources. If I had an AC input, I would choose my AC line. If I have a DC input, which I do, I would choose my DC voltage. Go ahead and double click on that. So if you look through each one of these items, it has its own little graph that shows what this information pertains to and what a visual aspect of what the source will actually do. Now, if you chose a DC source like I did and you come to find out need an AC source, you don't have to place a new one. You can just come up to this checkbox up here and turn that on, and it will now turn on your AC line sources as available sources. So here's your 6 AC sources, and then your 12 DC sources are all down here. All right, I'm just going to go ahead and normal DC input, and I'm going to enter my DC voltage. Instead of as a number, I'm going to go ahead and put my curly brace V in, which will use that variable. You could also do the Gaussian or the uniform distribution that was in the previous voltage source, but I'm just going to go ahead and use the nominal here. Now, if you wanted to add measurements or change how your voltage and current probes look, you can, or you can, if you wanted to just disable them altogether, you can come up to these two tabs up here where you can turn off the probe or add measurements. Right, just extremely similar to how it works in DVM. I'm just going to go ahead and leave everything as default and press OK. All right, now I have my source and I'll drop it across those 2 points. All right, next we're going to talk about the power supply loads. This slide shows all of the possible loads that are available. The loads can be either 2, 3, or 4 terminals, which mimics the DVM loads. And just like the sources, all of these contain internal voltage and current probes, each with selectable measurements. So let's come back to our schematic. Here is my load here. I have a resistor defined by some variable called R load in parallel with the current supply. So what I'm going to do is come back over to my part selector and choose my power supply load. Double click on that. And just like the sources, each one of these items has an image and some information pertaining to what is defined up here. So that way it's easier to visualize what this load is actually doing. And what I am going to do here is, or in each one of these loads is selectable by 2, 3, or 4 pins. The only caveat to that is the Bodie plot load, which we're going to use. This one has to be either a 3 or 4 pin because the perturbation source is located within the load. So it needs to be either 3 or 4 pin. We're going to go ahead and update our load resistance to be the R load, just like our resistor that we currently have. And what we could do is we could come up to our voltage probe, enable, disable, add measurements, same thing with current probe. One extra item this has is how to manipulate the Bodie plot probe as well. I'm going to leave it all as default, press OK. And for right now, I'm just going to drop this down here. And I want to delete, my load here. But I also, because the perturbation source and Bodie plot probe is located within this load, I also want to delete this information as well, or these items as well. So I will go ahead and drop this here and then wire up my sense pin. Now I should be able to run a simulation. Let's go ahead and run another AC simulation. And what we should get is exactly the same information as we did before. So let's go ahead and open up this guy. Now, because this has this Bodie plot probe has different settings, it's going to appear on a different waveform, or a different graph. So I'm just going to go ahead and select this gain curve, do a Control-C, come back to our original graph here, and paste it on top of that. It's on. Let me go ahead and make sure all of these are on the same axes, and there you go. You can see that it overlays nicely. So by changing the power supply or changing the load to an actual power supply, it's not changing anything. It's exactly the same. Now, one of the great features of these power supply sources and loads is the ability to easily convert them to DVM sources and loads. If you have a DVM license, all you would need to do is select your sources or your loads or a combination of all of them. Right-click that device, and then there's this upgrade to DVM source load. Now, when we select that, it's going to tell you what type of properties it's changing, but you'll now see that these are DVM sources in DVM loads, which is very nice. Now this schematic is ready to be upgraded to DVM and to use the full capabilities of DVM. If you have a DVM schematic and you just want to mess around and do some non-DVM stuff, you can do the same thing. You go ahead and select these, and then you can downgrade to just a normal SIMmetrix SIMPLIS source and load. Alrighty. So this is a quick review of all of the items that will be available in SIMmetrix SIMPLIS version 8.4. Items covered today are the capacitor and inductor conversion tool and the power supply sources and loads. Also available are in separate videos is an overview of the magnetics design module and the C-code DLL defined digital devices. When a future webinar is scheduled, it will be available on our training page, which is www.simplis.com/training. Thanks for watching. Have a great day.